Welcome to Chapter 39 on the mold tools. We've got this part, which we're going to pretend is an injection molded part, even though it looks much more like probably some form of thermoforming has been used to create this part. But in any case, it could be injection molded, and we're going to treat it that way. And we're going to use this part to look at the mold tools. This is just an introduction, so we're not doing a real in-depth demonstration of the mold tools, but the mold tools contain some general surfacing tools, and then they contain some plastics tools, and then they have the mold tools proper. Mold tools really encompass a process which involves a step-by-step procedure. The first part of the procedure will be to insert mold folders, and this will be just like other things we've done, like weldments and sheet metal, where there are some folders or some items in the feature manager that SolidWorks uses to identify this particular dock. By clicking on this Insert Mold Folders, you can look under the surface bodies and see we have a cavity surface bodies, core surface bodies, and parting surface bodies folders. These folders just organize various surface bodies so we know how they're being used. In general, this is how SolidWorks mold tools work. You will create a parting surface that goes all the way around the part, and it represents the mating surface where the two parts of the mold come together. And that obviously comes right up to the edge of the part. It'll be just a surface that goes all the way around the part. And then you will have the cavity surfaces, which will be all the faces that you can see from this side, and the core surfaces will be all the faces that you can see from this side. There will also be certain things like shut-off faces that will go, say, into this hole to separate the cavity from the core. And on this part, we're eventually going to have to make a decision. Is our parting surface on the top of the thickness or on the bottom of the thickness? You've got to be very detailed about how you lay out your part for molding. And then SolidWorks will take all of those things into account and take a bigger block of material, cut it in half with the parting surface, and then use the rest of the surfaces to also make cuts to completely divide the top side from the bottom side. In this case, the top side would be considered the core because it's got a male section that sticks down into here, and the bottom side of the mold die would be considered the cavity because you have to have a female cavity here to accommodate the bowl of the detergent scoop. So now that we've started with the insert mold folders, let's keep going with parting lines. I should note that whenever you're designing a mold, you need to do one of several things. You need to actually be the guy that's going to build the mold, or have a lot of experience doing this, or be working directly with one of the other two guys who's either designing the rest of the mold or building the rest of the mold. Plus, be aware that what SolidWorks does is not mold design at all. The mold tool's name is kind of a misnomer because really all we're doing is creating the cavity and core blocks that are very often created as inserts that go into a mold die. The mold die is going to involve certain things like cooling lines. You're going to have a lot of bolts, runners, sprues, injection, bushings. You may have a multi-cavity die. The mold die could be, the size of a VW. Or it could be something smaller that would fit on a desk. Parting line functionality starts out by determining the direction of pull for the mold. So what direction does the mold have to go to open up? And I'm just going to select this face. SolidWorks puts an arrow in indicating that that's the direction of pull. That's correct. A lot of molds have a minimum amount of draft, and so you can check your model to see how it relates to that. And you can see that everything we've got is pretty good. The one thing you should look at, though, is that this thickness face has 0 draft, or it has less than 1 degree draft. The green is going to be the core side. The red is the cavity side. You can use this functionality to automatically create splits, but we're not getting involved with that level of detail here. Okay, next we need to select our parting lines, and I'm just going to select the bottom side, the bottom edge, and I'm going to right click here and see if we can't get select tangency to do a lot of the work for us. Okay, that did a lot of work, so let's do some more like that. Right click on this edge and select tangency. Okay, let's take a look and see if that's selected everything. It looks like it has. The message up here will give us an indication also. It says the parting line is complete, but the mold cannot be separated into core and cavity. You may need to create shutoff surfaces. This is part of the process that will come a little later, and it's just referring to this little hole. Okay, so let's click the green check, and SolidWorks adds a parting line feature. There's one thing that some people do with an existing part like this. You can select all of your features, and I did I selected the bottom one and then shift selected the top, and then right click and add to new folder. And I'll just call this features of plastic part. Okay. Sometimes people will actually take the original plastic part and insert it into a new part so that there's only a single feature at the top of the tree. That's another way of doing it. Okay, so we've done the mold folders, we've done the parting lines. Now we'll do shutoff surfaces. SolidWorks has already identified these for us. It's a great automatic tool, and you just click OK on that. Notice it fills that in with a surface already, and you may see this modeling that's on here. This is what you get when you have a surface or two surfaces that are in the same place, pretty much. And so what we have is we have the solid body from the plastic part that we designed, along with cavity and core surfaces for the rest of the part. The faces for the cavity and core are just surfaces that are copied from the solid. Okay, and they're established as green and red for cavity and core. Let's take a look at the parting surfaces. We already know where the parting line is, and in this part it's been very easy. This would have been better for me if I had established the direction of pull from the very top face, or actually the very bottom face of this lip. Because you see SolidWorks is trying to pull the parting line back down to that direction of pull. I'm just going to make the parting face a lot bigger. In some parts it won't be this easy, but I've selected this part just because it's fast to go through for this introduction. Okay, now we've got everything we need. We have the parting surface, we have the cavity and core, we have the shutoff surfaces. This is everything we need to proceed to the tooling split. Now the tooling split wants me to select a plane, and so because I know this parting surface is planar, I'm just going to pick that. And then it wants me to draw essentially what my insert block is going to look like. So most of the time you'll have established sizes for your insert block, and you can use the dimensions to establish those sizes in this sketch. Now when you exit the sketch, SolidWorks is automatically going to kick you into the extrude in two directions mode of the tooling split. And again, you're probably going to have established sizes for the thickness of the two sides of this block, because we're just creating one extrusion, but SolidWorks is getting ready to split this into two separate pieces. Okay, so I'll click OK on this, and SolidWorks does its magic. And now notice our solid bodies has increased to 3. We have the plastic part that we started with. We have what's essentially the cavity side of the mold, and we have the core side of the mold. Now I can hit F8 to turn on my display pane, and I can turn off some of these parts to make it easier to see what's going on. Right click here and hide all of my surface bodies. So this is the core side of the insert block. This is what someone will actually machine or EDM or however they create this. You see it's got a little tab here for the shut-off hole that we mentioned earlier. You can see it's got the thickness. All the features that are on the inside of the part are here. And then we can turn this off, reverse that, and look at the other side of the mold block. Okay, so this is how the SolidWorks mold tools work. There's an additional function of a core, and this is not to be confused with the cavity and core. This is really what they mean is a side core. For example, if we had some sort of a feature that had to be molded in here, but could only be done with some sort of a side action. They could have found a different word other than core, because core is already being used in a different sense, so that might be a little bit confusing. In any case, this is just an introduction to these tools. You'll find more involved information in the course of the chapter in the book.